Welcome to Unit Price Visualization and Estimating tool, or UPVET. This tool is developed specifically for Caltrans, and this demo website has sample data from California Department of Transportation. This tool enables you to generate visualization of unit prices of different bid items across the state of California. And the visualization can further be used to generate estimate of unit price of specific bid item. To begin with this, let's take a look at this overview of the screen itself. First, we have unit price visualization map section where all the unit price visualization will be generated. Filter section will let you enter different parameters to customize this map generation. Quick map update will let you turn on and off different layers. Unit price estimating, once you have the map generated, then you can use this section to estimate unit price. And then there are different options to customize the unit price generation as well. And this database update should be done only if you do not have coordinates for your projects, and instead you have mileposts. And you do not need to do this for every project. Now to start, let's enter a bid item description that you're interested in. So let's say you're interested in generating estimate for concrete item. Let's say remove concrete. Now as soon as you select the item, its bid item ID will be copied here, and you can generate unit price by clicking here right away. So this basically shows unit price visualization map of concrete removal across the state. Now the green one basically here shows that it has very low unit price, whereas red one in most of the location shows that it has very high unit price. So $650 per cubic yard or $76 per cubic yard. Now this unit price visualization map section has basic navigation function. So you can zoom by scrolling your mouse wheel, or you can pan by basically dragging this map wherever you want. Now sometimes your map might be lost because you moved it somewhere and maybe you zoomed out or zoomed in. So if you don't know where your map is, you can basically reset map and it will bring it to the original position. Now this map right now shows the unit price visualization in different colors, but on top of that, it also shows the county layer, which you can turn off or turn on. So this is the county and its name. The visualization layer as well, you can turn it off if you would want to. Also, the unit price levels here, you can turn it on or off. It does not delete the dot. It still shows the dot where the project is located, but the unit price itself is not shown if you uncheck this. Now, instead of county, you might enable the district layer, for example. So it shows all different districts across the state, or you can turn on the highway layer. You can turn on multiple layers as well, but this is going to be very messy. So you might just want to keep one of the layers on at a time. Now to generate estimate, you can click anywhere and it'll basically generate the estimate. So $188.37 for this location. Now, if you are interested in the actual estimation, you might be entering the project location information instead of just clicking on a map, because you have no idea where a particular highway is and so forth. So instead of that, you can just go here, for example, 10 STA 132 26. So you can put it here and then you can do estimate unit price, and it basically generates estimate $178.19 for the location for which you have provided the milepost. And this is the coordinate that corresponds to this PM detail. Now this allow multiple estimate map, it will allow you to generate not only one at a time, but multiple estimate at a time if you have this need for any region. If you uncheck this, then you can see only one estimate at a time. You cannot have multiple estimate. Again, enable multiple estimate on the map, you can have multiple estimate. You can generate it from here by clicking there, or also you have option to enter more details separately instead of entering the PM string directly. Alternately, you can also provide the coordinate and you can estimate from there as well. So all three options does the same thing. Depending on what information you have, you can use one of the three methods. Now, right now it's very messy. There are too many estimates I've created. So if you want, you can clear the estimate by clicking here and all the estimates will be gone. Now the next is show unit price data. Now there are several projects from which the unit prices are utilized here. So you can kind of see those. Right now it only has 1, 2, 3, 4, 5. In your real database, you will probably have a lot more data here. So the details about those data points or the historical projects can be found here once you check this show unit price data table. So the total number of projects, 5 projects were available, unit price range from 76 to 650, and the average unit price was $260. So the project ID, BDR, all of those details are given right here. Now let's say you're interested in all the estimates for this particular location, right? So first I just generated estimate for the removed concrete, $178.19. Now let's say I'm also interested in excavation for the same location. So I'm going to start to type excavation, roadway excavation, and I can again generate unit price visualization map. Now remember, this data, this location information will still be there. So roadway excavation has more data points and hence it's taking longer to process and generate this visualization. Again, this PM detail string is still there. Also the latitude and longitude are still there. So all of those data you enter in unit price estimating will stay there. Now this is very messy, so I might even want to uncheck this unit price labels. Now I can see much more clearer and cleaner picture. So again, you can check highway, for example, and all of those points should be in the highway. Now, I checked this before, so it has the data here. Now let's take a look at this. It's using 533 points. So if you scroll down, it has tons of data. If you scroll to the right, it has a tiny scroller basically showing there's too many data points. Now, utilizing 533 projects from entire bid history may not be a wise idea. So if you look here, you have data from 2009, 2008, 2012, and so forth. So let's say you're interested in using only the latest data you have. In this case, we have only 2012 data. And you can generate it again, and you will have a new visualization in a few seconds. The new visualization looks like this. Now again, you can take a look at this and you might be saying, okay, the project I'm gonna work on, it has about 1,000 cubic yard volume. And here the item quantities varies quite a bit. So from 5 cubic yard to something like 12,000 cubic yard or 17,000 cubic yard. So I'm interested in about 1,000 cubic yard of work because different quantities, the unit prices will be different as well. So instead of just entering perfect 1,000, what I'm going to do is I'm going to do something along the line of, let's say I'm going to look at quantities from 500 to 1,500. Then 1,000 then 1000 will be somewhere in between, and I'm going to use just a limited number of data. So that's how it looks. Now you have more refined data based on both the year as well as the quantity of the item. And as you narrow it down, your accuracy is likely to increase. The accuracy of the estimate is likely to increase. Again, if you're interested in generating unit price of excavation at this location, just click the estimate unit price, and there we go. Now we have estimate for excavation at this location. We did estimate for concrete removal before. So that's the estimate part. I'm going to check off the unit price data for a second. Now there are a few things you can do to customize the accuracy and the calculation methodology for this unit price visualization and estimating tool. Those are in the options section. Now the first one, pixel size, this does not change the accuracy of visualization, but it will improve the speed. What this is when we're generating this map, for each pixels here in the map, it will try to compute unit prices so that it can generate the colorful map. Now instead of each pixel, we're doing a box that's the size of 4 pixel by 4 pixel. Now let's say you want to do the calculations faster, then you can increase this to, let's say 10, or let's say even 20. And you can compute it again, you can generate the unit price again, and now it looks like a box because it's looking at a box of size of 20 by 20 and then generating unit prices for all of those. Now again, this does not affect the accuracy of the estimate. If you click the estimate here, it's 55.83. Let's change this pixel size to 2. It's going to take a while to generate now. Let's generate the map again. And let's try to estimate again. Again, it's 55.83. The accuracy does not change by changing this. But if you notice the time difference between those two, again, I'm going to try to do 20. It's going to be done in no time at all. There we go. Whereas if you do 2, it's going to take a while before it can do all the calculation. Now the inverse power basically shows how rapidly the influence should decrease as you go further and further from historical project. 2 is the default. Anything from 0.5 to 3 would be reasonable depending on the project. You can customize it. So let's say it's 0.5. So you want to have slightly more similar impact even if the distance is higher. Then the unit price estimates, now the value will change. So this is how it looks if you try to be more uniform by taking account of farther points with about similar effect. Now instead, if you increase this, let's say to 3, or let's say to demonstrate the effect, let's go with the 10. If you increase the inverse power, then the closer points will be very dominant at determining the unit prices. So 22, it's 22 everywhere. 11, it's 11 everywhere. 77, it's 11 in this region. So again, something like 3, 2 would be a fairly good number. Now, next 2 items, those also affect the accuracy or basically the methodology to compute this estimate. Now, if you do closer points only, it means now we're going to look at maximum of 12 points to compute this estimate at any point. And when I look at this estimate, I also mean all the estimates across the state. And the maximum distance right now is 1,000 feet, which is about the length of California in diagonal measure. So basically meaning all the points from the entire state is included. Now let's say, assuming that contractors bid to projects about 100-mile radius, this distance is in miles. So you can do 100-mile and you will see something interesting here. So now at this point where the mouse cursor is, there is no project that's within 100-mile radius, no historical project. So this distance up to from 11 to this green circle is 100-mile. From 22 to this circle is 100-mile. Whereas at this point, there's no other estimate, no other historical data you can use because it's too far from any historical project. So again, depending on how many data points you have, you might increase or decrease it. If you have too many data, then you might just choose the closer ones and hence decrease that distance. If you have too few data, then you might want to increase it to cover the entire state. Now, this number of projects, depending on, again, how many data points you have, if you have too many data points in very close proximity, then you might just use, let's say, 4 points. That's the closest, 4 points that are closest to the estimating point. Again, estimating point here or any location in the map. And if you generate the estimate after changing this parameter, the estimate value will change again. Now it's only looking at the closest 4 point for this estimate, which is probably this, and this. So 80, 30, 62, and 77. If those are the closest point, then it's only looking at those points to generate estimate for this location. Now compute latitude and longitude from post mile. This will take a significantly more time, which basically means if your database does not have latitude and longitude computed already, you can check this so that latitude and longitudes are computed on the fly. What I'm going to do is I'm going to try to have as few points as possible to show how long it takes. So let me take quantity from 600 to 900. And let's generate without this checkbox first. So it's taking about 3 seconds. Now, if you check this, what it basically means is this latitude and longitude here are not available. So it's going to look at other information, which is basically here we have post mile detail for start and end. It's going to use those information to first calculate the latitude and longitude for each project, and afterwards it can plot the map. So right now it's checked. It's going to take quite a bit of time. Actually, it did not take a whole lot. If I try to compute it for the entire item, it'll probably take quite a bit of time now. In previous case, we only had 5 points, so it did not take any significant amount of time. But now it's taking quite a while, quite a bit. So as you can see, it's taking a lot of time. There we go. Now it's plotted. So compare this to one where we don't have to compute this ourselves. And it is taking fairly fair amount of time, but now it's here. So if you have to generate this latitude and longitude on the fly, it's going to take longer. So to basically overcome this limitation, there's a database update tool, which is if you don't have those longitude and latitudes in your database, what this does is once you update this database, it's going to compute this latitude and longitude for all the historical projects, so that once you have those data, you don't have to check this again. It will be available for future purpose. Now you can choose to update the entire database, which is if you uncheck those and click this, it's going to take a long time to update the entire database. Or let's say you have all the data till 2016 that has coordinates, and now you only need to convert coordinates for 2017 projects. Then you can just do 2017 here and do update projects in the database, and it's basically going to look at only the project that were led in 2017 and generate latitude and longitude for those projects only. Also, there's a checkbox which is basically saying if the latitude and longitude are available for the points we're interested in, projects we're interested in, then don't generate it. Try to compute it only the latitude and longitude are not already available for those projects. And then there's help and pro tips. So those things you can take a look as well. And most of those boxes or sections you can toggle. So if there's this caret sign, then you can basically click it and it will toggle, basically show and hide the content of the section. Now the final thing is there is the print output. So if you are interested in printing this output in a PDF or in a paper, then you can click this print output. And there we go. So it shows all the filter parameters and other calculation parameters that you use to generate this map. And if you have estimate here, let's say we just have an estimate here, then you can also include that estimate. It will also be included if you have any of those estimates like this. So again, so we have this estimated point as well. Year range selected, no, so none of those ranges were selected, so there's no value that's displayed. Inverse power of 2 was used, maximum distance of 200 miles was used, number of projects were 4 closest points were used, and estimate at this particular location is $25. And it also adds the date on the top. Now if you have any of the range checked and you generate it with those checkboxes in mind, then it will also show those parameters in the printout. So year range selected yes, 2012 to 2012, and quantity range 600 to 900. So again, you can print it as a PDF or print it in actual printer. So that's pretty much all you need to know